We're going to review the topics in this first chapter, which is on linear functions and systems. We're going to go over some of the major ideas and get into some of the details in order to see the big picture of what we've been working on. So the three standards that we're focused on for this at the end of the year, the end of this chapter test, is standard 3, which is solving, standard 4, which is graphing, and standard 6, which is models and patterns. So first of all, when we talk about solving, we have three methods that we've solved. We graphed, we used substitution, and we used elimination, which is also called linear combination. So first of all, the graphing one. So to solve, you can use graphing here. And what you look for is you look for the intersection of the graphs. So as an example, what that could look like is if you've got a graph, maybe you're going to graph two lines. You see try to find a point that they intersect in, or maybe they don't intersect because they're parallel, or maybe they're the same line, so it's the entire line. Or maybe we have a graph of a parabola. The parabola looks like this, and then we have a line that gets drawn like this, and the intersection of that are these 2 points. So you're looking to find the values where the x and y values where they intersect to solve using graphing. Now the other methods that we used were we used substitution. And the last method we used was called elimination. Sometimes called linear combination. So we're going to refer to it as elimination. Now when you do substitution, what you try to get is you try to get either x equals something, or you get y equal to something, and then you substitute into the other equation. So x equals or y equals on one of the equations, substitute into the other equation and solve. With elimination, what you want to do is you want to line up the equations. They've got to be in order, the same order. Then you want to get opposites for one of the variables by multiplying by a number that, by the entire equation, that will get them to be opposites. And then you're going to add together to eliminate one of the variables and solve. So that's the basic steps for doing both of these. And they both have, substitution is nice when you have one variable that doesn't have coefficients. And elimination is nice if you have the x, the y, and the equal signs all lined up. All right, now, so that we have those three methods for solving, let's talk more about graphing. And a lot more detail about the graphing that we want to go through. So with the graphing, we'll start with saying that you're going to be using your graphing calculator. Now you have to know how to use that graphing calculator. And the graphing calculator is going to help you to do not only do operations, like for instance, up here for solving, one of the types of solving problems we have to do is our word problems. So when you have the word problems, we'll use either substitution or elimination, but then you're going to use your graphing calculator because the numbers tend to be large numbers that you might have to do the multiplication for. Now, for graphing calculator, you have to know how to find the table and use those table values to be precise points on the graph to be able to plot those points and graph them. Then we also did piecewise graphs. Now with the piecewise graph, you might use your graphing calculator to do each of the pieces and then make sure you restrict them according to the domain that they have. And then we looked at with our graphing, we then looked at doing domain and range. So domain, remember, is finding out the x values that are covered on the graph. The range is finding the y values that are covered on the graph. We also did increasing or decreasing intervals. So finding out when going from left to right, the graph's going up is increasing, going down is decreasing. And then we also did for this, we did positive intervals and negatives. When is the graph positive is above the x-axis, positive y values, or when is it below the y-axis, those are negative y values. And all of these we did using interval notation. Interval notation helped us to use shorthand for doing the notation for what the x's and y's are on the domain and range, or the intervals for these. And we also use set builder notation as part of this, but most of the time we resorted to interval notation because it was shorter. And just remembering that the parentheses we did when we had an open dot, or we did not include something. Also, if you ever put it on infinity or negative infinity, you're going to use the parentheses on it. And then closed interval notation is when you have a closed dot, or it includes the number for that. Okay, so that's information that we have for using interval notation. We also did mins and maxes, minimum or maximum. And then you label the y value as the minimum, maximum, because we're talking about, is it the highest point a maximum, that's the y value, or the lowest y value is the minimum. And then we did inequalities with graphing. Remember we did this, when we did these, we did the shading with these graphs. Okay, and we also looked for where they overlap. So let's put shading in here. Shading the graph. And then also where they overlap when you have a system where you have more than one inequality to graph. Where the graphs overlap. All right, so a lot of detail in graphing. Okay, so make sure you use your graphing calculator well on this. And then models and patterns. This is where we did arithmetic sequences. Okay, we had two forms we did the arithmetic sequence. We had the recursive form. And that form looked like a sub n equal to, you had two lines. You filled in the first value here for n equal to 1, and then you did the previous number plus the common difference for n greater than 1. So it was defined by what did the sequence, the list of numbers, what number did it start with, and then what do we add on each time. And then we had the explicit form. The explicit form was using the same information, and that was going to be if we have a sub n equal to, and we had the first number plus n minus 1 times the common difference, the number that we add on each time. But we're doing multiple times, so you multiply by the number of times, by that common difference for that number of times to do it. So this is a summary of the major ideas that we have from what we did with linear functions and systems. We did solving, we did graphing, and we did models and patterns. So you want to look these ideas over, look at the details in your notes, review over some of the videos to help you prepare for the test.